Ladies and gentlemen, welcome to your last unit. Unit 7, Chapter 7, Similar Polygons. Similarity. Alright? So, this idea of similarity, it's kind of tied to congruency, but there are some definite differences, and that's what we are going to explore today. So we say that figures that are similar, and we use this symbol. Notice this is just the top of the congruent sign. Okay, so the symbol is just the top part of a congruent sign. Well, they have the same shape, but not necessarily the same size. Okay, there are tons and tons and tons of examples of polygons that are similar, polygons that are not similar. I'll go with something pretty basic, I should say. I could go something like this and say that all of those sides are congruent. Then I could go ahead and draw maybe a bigger triangle that also has all the same sides, but they're different. Maybe this is a measurement of 2, 2, 2. This is 4, 4, 4. These are the exact same shape, but different size. Now, two triangles that are not similar, remember, not similar means they do not have the same shape. So again, there's tons of examples of triangles that are not similar. I'm going to go with the first one that comes to my mind. If I have a right triangle, and then I come over here and I draw an equilateral triangle, or equiangular triangle, these are not similar. Okay, these two triangles are similar. These two triangles are not similar. Why? Again, they're not the same shape. Okay, so as we move on a little bit, this is kind of the big takeaway from this lesson. Okay, two polygons are similar if and only if their corresponding angles are congruent and their corresponding side lengths are proportional. Alright, so these are the two checks that we're going to be using. The first check is for corresponding angles to be congruent, and then that second check that we're going to be doing throughout this chapter is checking to see that the sides are proportional to one another. Okay? So if we look at this picture to the right, we have A, B, C, D, E, F, G, H. We notice that all of the angles line up with all of the angles over here. If we tested, we could do, 12 divided by 6, that's 2. 10.8 divided by 5.4 is 2. 8 divided by 4 is 2. 10 divided by 5 is 2. So notice, what did I do? I really just found the ratios of the corresponding side lengths, and we noticed that they all matched up, which means in this case these are polygons, they are similar. So A, B, C, D is similar to E, F, G, H. Alright, the last little piece of note-taking that we need before we move on and do some problems is this idea of similarity ratio. A similarity ratio is the ratio of the lengths of the corresponding sides of two similar polygons. So the similarity ratio of ABC to DEF, well, you just need to pick one pair of corresponding sides and find the ratio of those side lengths. So if I'm going from ABC to DEF, that means I want to pick a side in ABC. So how about AB? And we need to put that over the corresponding side in the next triangle. So if it was AB, then I'm looking at DE. Okay, DE is what corresponds to AB. So AB over DE, and then we plug in, 3 over 6, or 1 over 2. That is our similarity ratio of ABC to DEF. Now hopefully we can see, to go backwards from DEF to ABC, again, we just pick out a side from DEF. So again, I'm going to pick DE, the one that I already have highlighted. And I'm going to divide it by, or create the ratio between DE and its corresponding side. Once again, is AB. So now, instead of 3 over 6, it's going to be 6 over 3, which is 2 over 1, or 2. And both of these answers are acceptable. A lot of the times people get a little hung up on this fact that it's a ratio, so it should be a fraction. I'm okay with either of these. Okay? So, let's do some problems. If we take a look on the next page at something like number 1 and 2, this is probably the easiest stuff from this chapter, okay? We just need to identify the congruent angles, the pairs of congruent angles, and the pairs of corresponding sides. So, if I look at this picture, it looks like both A and E correspond to one another. So I would say angle A and angle E. If I kept going around, B to F, angle C and angle G have the same arc marks, so they are congruent. And lastly, D and H. One thing just to be on the lookout for, I know that might be kind of tricky. Yes, both A and D, E and H, they're all right angles. It is really important for you to understand that A has to line up with E. A does not line up with H. And why is that? Well, that would kind of be going out of order. If I went A, B, C, D, and then I started with H over here, I wouldn't be able to get to the angle that corresponds to B. So again, the order of the lettering really, really matters, and that's something that we're going to have to work on in practice. Now for sides, hopefully, shouldn't be too bad. If I go AB, side AB, well, that corresponds to EF. And if I just keep going around, BC and FG, CD and what is it? To GH, sorry. And lastly, DA and HE. Okay, so those are my matching pairs of corresponding sides and angles. When we take a look at something like number 2, we do have to check the orientation. This is kind of what I was talking about. We have to go in order and make sure that the order is done correctly. So again, I'll make my little table. I'll call this angles, and I'll call this sides. My angles, well, if I start at Q, for example, Q is this double arc mark, so I have to find the double arc mark in my other picture, or my other triangle, which is Y. And then maybe I'll go no arc marks, so S, angle, that's angle S, and angle X. Why? Because X doesn't have an arc mark, just like S. And lastly, R, angle R, and angle Z. Okay? So again, when we do these sides, it's really, really important about the order. Let's say I go QS. Where in my other triangle do I see a side that's proportional or kind of matches or corresponds to QS? Well, here I'm going to use my angle markings to help me out. I went from Q to S, so I went from double arc mark to no arc mark, which means I need to do the exact same thing in the other triangle. Double arc mark to no arc mark. Y, X. Excuse me. Sorry again, and actually I didn't apologize yet. My voice is a little scratchy. I was coaching this morning. I was hollering quite a bit. So sorry. Okay, let's keep going. SR, no arc mark to single arc mark. No arc mark to single arc mark. X to Z. And lastly, RQ, single to double, which means once again I have to go single to double, ZY. Okay, so guys, I hope that wasn't too challenging. I think this is something that we can do, and at least with some practice, I would say will not be a super hard concept for you guys to grasp. Now, as we move on, now we're getting ready to prove if something is similar or not. So here we have to go back to that definition from page 2, the middle box. There are two check marks, or two things you need to find to be true in order to call polygons or triangles or whatever, any shape, similar. Okay? And they are these two things. Angles must be congruent, and sides must be proportional. Okay, so I'm not going to go super in detail about these angles because I'm hoping you guys can see that if I have double, double, single, single, and then in the exact same order on the other polygon I have double, double, single, single, then I'm good. This is good already. I know that my angles are congruent. Alright, now the sides. Here we're going to have to set up some ratios, kind of like what we were talking about on the page before, these similarity ratios. We're just going to kind of have to go figure out, like, if I'm talking about WV in one triangle, well, WV is going to be the same as LM in my other triangle, or sorry, in my other polygon, my bad. So this is equal to 25/15 or 5/3. Why do I care about this? I care about this because now I know that every single proportion that I set up, when I set up the next sides, or the proportions of the other corresponding sides, I need to get 5/3, okay? They all have to have the same similarity ratio. So let's check it out. Let's keep going. VU lines up with MN. Well, VU is 15 over 9. If I divide both top and bottom by 3, what do you guys notice? I have 5/3 again, so that's good. There's one other set of sides that I need to test. I don't need to test WX and LO because I basically just did that with VU and MN. But I do need to check XU and ON. So UX, I'll call it, U to X, N to O, 35 to 21. Divide both top and bottom by 7, and what do we get? 5/3. This is good. This is what we wanted to see. This means that our sides are all proportional to one another. Okay? The corresponding sides are all proportional. So I know that my polygons are similar. Now for the ratio, we already got it. Okay? The similarity ratio is just 5/3. In the similarity statement, that is just you telling me that this shape is similar to the next shape. So I'm going to call this first shape W, V, U, X, W, V, U, X, and it's going to be similar to L, M, N, O. Alright? Alright. Let's try another one. Again, I need to figure out what are the two things that I'm looking for. I need angles to be congruent, and I need sides to be proportional. Rectangles, PQRS, TUVW, that means all of these angles are right angles, which means I don't even have to show any work. Yes, the angles are all congruent. I know it because they're all right angles. Let's now test for the sides being proportional. PQ is one side, and if I look at PQ, it has to line up with TU in my other rectangle. So PQ, 12 over 16, that reduces to 3/4. Alright, let's check the other sides. Once again, PS, TW, 4 over 6, 2/3. Alright, these proportions, or these ratios I should say, are not equal to each other, which means that our sides are not proportional to one another, which means our rectangles are not similar, and, sorry guys, I just realized I was off the page. If they're not similar, then there's no ratio, there's no statement. Okay? Okay. If we take a look at one more at the very top, number 5, this one hopefully should be pretty easy. What do we notice here, guys? I have a double arc mark in this picture. I don't have a double arc mark over here. What does that tell me? That tells me that E is not congruent to any angle in our other triangle. Okay, so angles, when I check, are the angles congruent? I can immediately say no. I don't have to do anything else. I immediately know I'm not similar. And then I'm done, okay? Those are the really nice and easy problems. You don't even have to test for the sides. If the angles are not congruent, then there's no reason to go any farther. Okay? Alright, let's move forward. I'll try to get done in the next few minutes. I know this one's getting a little longer. We have similar triangles, okay? That's what the statement says. It says triangle RST is similar to triangle GHJ. So, RST, GHJ, that means that the sides are proportional to one another, okay? So I just need to set up a proportion that's going to help me get this missing value for x. Now, it does not matter which sides you choose, okay? You can go 10 over 15 if you'd like. You could go 8 over 12 if that's what you like. You're going to have to use the x and the 9 because that's what we're trying to solve for. But basically what I'm just trying to say, you don't need to get all 3 to make sure in this case. Why? Because I'm already told that they're similar, so the sides have to be proportional. So I'm going to go RS GH needs to be equal to RT over GJ, and now I'm just going to plug in. 10 over 15 has to be equal to x over 9. So when I my bad guys, sorry. When I cross multiply, I end up getting that 90 is equal to 15x, or x equals 6. And that is our answer, x equals 6. No units, so we're done. Now, 7 is similar. It's a little bit tougher because we have an expression rather than just a variable alone. So notice here, EFGH is similar to TUVW. That kind of tells me the order. Like, if I'm looking for WV, notice WV are the last 2 letters. That means it's going to have to be proportional to GH. Okay, so I know that for sure I'm going to need to set up VW is equal to GH. Alright, so that's good. The other thing, I mean, you can kind of pick now, guys. Do you want to use the 20? Do you want to use the 30? I'm going to go with the 20. Okay, so I want to use WT. If I want to use WT, well, W and T, or actually, let's stay green. W and T are the first and fourth letters, which means they need to be similar. Sorry, WT needs to be similar to HE, because H and E are the first and fourth letters in the other polygon. So now I'm ready to plug in 3x minus 1 over GH is 7, and that's going to be equal to WT is 20, HE is 4. Alright, now I cross multiply. Alright, so if I cross multiply, I'm going to end up getting 4 multiplied by 3x minus 1 is equal to 140. I'd probably distribute at this point. 12x minus 4 equals 140. If I add 4 to both sides, I get 12x equals 144. And we should hopefully know that x is 12. Okay? So now the last thing we'd have to do, I'm not asking for x here, I'm asking for WV, so go ahead and plug it in. 3 times 12 minus 1, well, that's 35. Okay? Last problem. Thanks for sticking with me. I'm almost done. This one shouldn't be too bad. We have a word problem, and you're going to see some word problems throughout this chapter. You're going to have to figure out how to do these. So let's read through. The Willis Tower is 1,729 feet tall and 195 feet wide. Mary bought a Lego set to build a model of the tower. Her model is 4 inches wide. We need to find the height of Mary's model of the Willis Tower to the nearest tenth of an inch. So, what I'm going to do, guys, is I'm going to draw a picture. A couple of pictures, actually. Alright, here's my Willis Tower. Really nice picture, right? I know that it's 1,729 feet tall, and I know that it's 195 feet wide. Now, any model that Mary or me or whoever makes is going to have to be proportional, similar to the actual building itself. So if I tell you and give you that the model is 4 inches wide, and we're trying to find the height, then I'm going to set up the problem just like that. Alright, again, the actual Willis Tower and a model of the tower are going to be similar to one another. So we can just draw pictures and make sure to put a variable where what we're trying to find. For what we're trying to find, sorry. Now, we already know that the angles are good. We know that we just need to set up the proportion that will help us solve this, because we know that the sides have to be proportional to one another. So if I go 1729 to x, right, that's from here to there, I have to do the same order in my other ratio, 195 to 4. When I cross multiply, 1729 times 4 is 6,916, and that's going to be equal to 195x. When I divide this by 195, I get that x is equal to 35 point, it says to the nearest tenth of an inch, so I'm just going to round this to 0.5. 35.5 inches. And that is the first lesson of our similarity unit. Big takeaways that I need you guys to think about as we move forward is right here, okay? To make sure to prove if something is similar, we know that the corresponding angles must be congruent and their corresponding side lengths have to be proportional. That is quite a bit of this chapter. Alright? Have a good one. Thanks for watching. Make sure to pause, rewind, do whatever you got to do, and make sure as well to please ask me questions if anything's not making sense. Have a good day. Peace.